Hi, I'm Nick Bonner for treestuff.com, and I'm here at the Edelrid World Headquarters. Martin, thank you so much for having us.
Nice having you here.
Martin, quickly tell us your role here and what you do.
Yeah, here at Edelrid, I'm the head of the rope development department. So basically what the name says, I'm responsible for the development of the rope, and as the manufacturing of the rope is here at our facility, a lot of the time is like making sure as well that production is running smoothly, and in case something is not, because we're working with textiles, then people are quite quickly at my office, so this is part of my job as well.
Great. And how long have you worked here?
I've been here now for a little bit more than 11 years.
Wow, that's incredible. There's a legacy with Tree Stuff and with Edelrid. Tree Stuff was the first U.S. company to bring Edelrid safety gear in when Blair visited us just about 10 years ago. And I got to say, I'm very proud to be here today and to kind of bring this full circle. And we're going to share with our audience today the entire rope making process, a tour of your entire facility, and showing literally each step in really high detail. And it's going to be good. I think that people are really going to enjoy that look into the technical side of it.
Hopefully, yeah.
When you design ropes for arboriculture or for tower or wind turbine, what are some of the main considerations or some of Edelrid's ethos? What are you trying to accomplish?
So basically, as we are working with safety equipment, for sure, safety is the most relevant part for us. This is not non-discussable. And then for sure, we want to make ropes being as suitable for the scenario of usage as possible. So first of all, we are thinking about what's going to be key for the usage in this scenario. So for example, for arborism rope, it's going to be abrasion resistance, for example, is one key factor. So this is one thing we're thinking about with the material we're using, with the way we are processing the material, etc., etc. And so for every scenario, we are thinking about what would be the ideal rope for this, and this is what we're trying to achieve.
Interesting. And how would you say that looking at something like needing abrasion resistance versus elongation, how does that translate into your research or your development process?
So unfortunately, producing or developing, I would say, standard rope is pretty easy for us. But in rope development, it's always, if you want to improve a certain factor, you always have to be aware that most likely the other factors and figures are going to drop down. So the most interesting thing is trying to improve one factor and try to get the others to stay the same, or at least not drop too much. And this is always a kind of a balance scenario we're working on. And this is what we do in most of the time, yeah.
I feel like you kind of mentioned that making a simple rope is easy. And I think a lot of people look at rope and think, the materials are very static's not the right word. The materials are known and the processes are known. What do you feel are some of the unsolved problems or kind of future problems for rope? Like, what are some of the things that you want to figure out but haven't?
So actually, it's the funny side is that some questions we believe are relevant for the future are very basic scenarios. So abrasion resistance, for example, we're talking about, everybody using a rope knows that this is a factor. Nonetheless, it's very, very tricky to get a testing set up, doing tests in a statistically valid manner. So this is something we're working on currently in order to improve that factor and to really prove that scientifically, not just like we believe this is the way, but really show this in figures. And for example, we believe that the treatment of ropes, which is currently mostly used for dry treatment, does have an effect on certain other factors. And we believe it or we do realize, for example, that the number of drops on a drop tests will most likely increase when you dry treat a rope. And as well, treatment might be interesting or is interesting for abrasion resistance. And then these are things we're working on one hand, in order to make our ropes as long lasting as possible. Then for sure, especially for the outdoor industries, environmental issues are a really huge topic we consider to be very interesting for the future. So working with materials not fully based on oil, basically. So maybe partially bio-based material and stuff like this. These are definitely driving factors for the future.
Interesting. And you mentioned the environmental concerns, and we also talked about abrasion resistance. And I think that on one side you have environmental concerns of production, but another thing that I know that Edelrid really cares about is making products last longer so that they don't need to be made again. It doesn't matter how much of the bad stuff you take out of production of anything is damaging to the environment.
Yeah.
And whether it's steel inserts in carabiners or increasing abrasion resistance, it feels to me like Edelrid is committed to having people buy less Edelrid stuff, like buy it once and it lasts.
I mean, we are very aware of the fact that our company is existing due to selling products. And as you mentioned, selling and manufacturing a product is always having an impact. And we are very aware of that. But if we're really talking about visions and where we want to go to, if we're talking about environmental friendlier products or friendly companies, this has to be the go-to way. So to really make your product as long-lasting as possible. And yes, recycling and stuff like this is a part of the story, but it's always the end of the story. And so if we can produce ropes or carabiners or whatever being as long-lasting as possible, this is going to be the best way to reduce the footprint. And this is going to be a long path up until that. But yeah, that's the vision we are working towards. Yeah.
Seems so easy, but in a world where things seem to be designed to fail and where they're updating our phones to make the batteries die, I think you kind of stand alone in that way, or at least in a small group of people. Should be very proud of that.
Yeah, we are. But as mentioned, I mean, we are very aware that currently we're still living on producing products, and this is paying my daily salary. But nonetheless, the idea for the future is to kind of change this, and this change is going to be slowly, but I think it's necessary. Yeah.
Great. Well, can you walk us through kind of at a high level how the rope starts as a filament and turns into a rope?
Sure. So first of all, as you mentioned, we're starting with raw material.
That's my gator now.
It was your gator. We do a lot of shoots over here now. No, so first of all, we're starting with the raw material, and the first part of the production, which is basically taken half of our facility, is processing the material in a way in order to get it ready to get onto the braiding machinery. So it's twisting of the material first, then for especially dynamic applications, we have to get more dynamic into the material than it has in the raw material. So this is basically done by a shrinkage, so shrinking the material. Then we have to get it in a processable way. So to get it on carriers for the braiding machineries, and the core on bobbins to run it through the braiding machinery as well. So this is basically the whole top floor of our facility. And when we've made that, then we go into the braiding machinery, so the braiding in itself. There we got a lot of options to make a rope the way we want to have it. So first of all, we do have two separate ways of setting up the machinery and the binding of the sheath material. So one option is the 1/1 braiding. So one yarn will run over the one yarn and then underneath the next yarn, or the 2/2 braiding. So one yarn will run over two and underneath two. This is the first step of making a rope or design a rope the way we want to have it. Then we have certain other factors. For example, if we're talking about stiffness in ropes, we are tending to make a difference between bending stability and pressure stability. So pressure stability is mostly driven by the amount of core we're pressing into a rope, to either get it very stiff or very loose in the touch, and bending stability is mostly driven by the speed we're pulling the rope through the machinery, so whether it's a very open or a very, very close break. And these are the factors. Then there might be a dry treatment depending on the rope and the usage scenario, packaging, check-in, and then shipping the rope.
A common thing that's mentioned in reviews or even a complaint about rope is that a rope will flatten out under a mechanical device. Mm-hmm. You could make a rope that didn't flatten at all if you want, or had extremely minimal flattening. But something that we found is that if the rope doesn't flatten enough, that the mechanical device won't actually be able to grab it. So it's really interesting to me how you are able to kind of keep all those different design considerations, in mind.
Absolutely, and I think that's one very important factor you're mentioning. When you're working with the rope is one part, and it's always going to be an interchange between the rope and the devices you're using for belaying or whatever. So this is very interesting here as well, as we have hardware development as well. We all have it in-house to do the testing. And yes, if you try to improve or change factors within a rope, you always have to check how it's going to behave in real scenario validation, and not only think about the rope, but always think about the behavior within scenarios you're using your rope.
From a development perspective, if you were looking at this rope and the decision came down to make it more abrasion resistant, what are some of the design or engineering considerations that you would do to change the construction or the production method of this rope?
Yeah. So first of all, in this kind of rope, we do use a very thick material for the sheath. So compared to normal dynamic ropes, for example, we use ×4 twisting. In this case, we use ×13 twisting. So way thicker material in the sheath material for the sheath. Second part would be, you were talking about the flattening of the ropes. This is a factor as well. So in this scenario, we did use a braided core. So we're braiding the core first, and then we're braiding the rope around this. The second benefit is this would be very beneficial for the splicing of the rope. So if you do a spliced end termination, the braided core will make it way easier to do the splicing on that. And these are some factors we're taking into consideration when we come up with a rope. As well, for the material we're using in here, the sheath material is polyester in that case, due to we don't need the ability of shrinkage. We don't really want it for a static or a semi-static rope, so we can use polyester. Plus, the polyester does have I would currently say, a different behavior concerning abrasion.
Interesting. When I buy or purchase or even just kind of evaluate a rope, one of the things that I always look at is what most people would call a pinch test like this. Talk to me about some of the considerations that would be made if you wanted to make the rope more flexible, so to make this eye smaller or to make it less flexible where it would not constrict so small. What are some of the things that you might change about the production or development?
So as we were talking earlier, it's always a combination, or we consider it to be a combination of bending stability and pressure stability. So if I want to make a very flexible rope, I have the two options: either to take core out of the rope, so to make it less pressure stable, this will make it softer in the touch or in the feeling, or to make the braiding more open, and then it will get more flexible as well. So these are the two factors I could use. Nonetheless, you have to be very aware that all the factors you can only use up to a certain point. For example, if I try to put out a lot of core length per meter of rope to get it very pressure soft, you might run into issues like sheath slippage in usage. So this is always something you have to keep in mind and be very aware of when you're designing ropes. So as mentioned earlier, if you're trying to improve one factor or push one factor to the limit, this will always have effect on the other factors. So you have to take that into consideration all the time.
When you started to design your tree climbing ropes, before any of this existed, what were some of the first considerations, or what was the first step that you took?
First step is thinking about what a tree climbing rope, what is special about tree climbing ropes. And that's what we had earlier. I mean, it's just like it has to be abrasion resistant because you're using it within a tree. Then the grip and the handling has to be very important because you're just like climbing up and down on the rope and using really the rope, and you're working with the rope in a tree. So first of all, we're starting with thinking about the scenario of usage and what are the challenges for the rope in this kind of scenario. And then we're trying to start to face these challenges and develop a rope as good as possible for this application.
And roughly how long does that development process take, right? You're going to make your first arboriculture rope. You've been making rope for 150 plus years. How long does it take from conception to production?
I mean, it's very tricky to say because it's depending on how standard, I would say, the development is. So if you're coming up with a tree climbing rope, and the idea, I mean, we know the scenario of usage, we know the material, and we do have ropes in our rope range. So coming up with a new rope would maybe last from the first idea to real going into production, I would say 2, maybe 3 years. If we're thinking about factors which are really more in an innovative way. So for example, we came up with more cut resistant ropes. We came up with mechanically recycled polyamide used within ropes. This might be developments taking a decade from the first test. So 10 years plus, depending how far it is off the normal standard you're producing, I would say.
I'm kind of shocked because you're not even phased by like the idea that 3 years or 2 years is a minimum. That's such a long period of time, and it really, I think, speaks to the level of commitment that Edelrid has. And then, maybe 10 years, and like that's a shocking amount of time to spend working on something. But I think that for the men and women that are putting their lives on these lines and using them around saws and braiding them against tree bark, that those things are really important. And I hope that the customers, I hope that you all appreciate the amount of work and effort that goes into producing these ropes. Is there anything about rope that you think people don't know or would want to know? Are there any like interesting facts? What's like your most interesting like gotcha about rope?
That's a real tricky question. Maybe I'm not the right person to answer it because, as mentioned, I mean, we are working here. I'm here for 11 years now, working 11 years in rope. So we are maybe now and then so focused on details that we kind of miss what actually people in the. So yeah, as mentioned, so we are looking so closely into details that we're some kind of stuck in there. But yeah, I think you might see a few facts during your tour through the production. I think the most interesting thing or the fascinating thing for people visiting us is that like braiding a rope is not only the braiding machinery. It takes this at least the same amount of effort. So braiding is one part of rope manufacturing, and the part which is before we even get to the braiding machinery is like a whole floor we need to get the material ready for braiding the rope. And as soon as people are here within our factory, they realize why a rope does cost some money if you buy it as customers, because they see that it's not that easy just taking material, setting it up to the machinery and run.
We were talking earlier as we walked through the facility about how much time is invested in making a hank of rope. And we talked about a set of rope being about 1,500 meters. That 1,500 meters, I think we figured out that it takes somewhere between 5 and 10 days to actually produce it nonstop going through the factory. So yeah. It's not as simple as, like you said, just taking the yarn, putting it on the machine, and bang, a rope is there. And as we walk through the factory, you're going to see all the different stages where the yarn becomes the twist, which becomes this, which then goes back to a twist, which then goes on to the bobbin. And it's really incredible the amount of physical and mechanical work that goes into the rope. But I have to say the thing that impresses me most about your facility and your process is the hand inspection. We'll talk about this and we'll show it either in a separate video or later in this broadcast, but we'll see 1 million meters of rope every month all go through the hands of an Edelrid employee, a physical test that checks every inch, every millimeter of rope. And I have to say I was shocked to learn that, shocked and impressed and in awe really of your whole facility and the level of technical automation, and individual care. It's very, very impressive.
Thanks very much.
Well, thank you so much for opening your doors to us and sharing this process with us. We're going to be here for a few days, and we're really interested to learn more about Edelrid, about some of your other products, production, the management, and yeah, just thank you so much. And I'm incredibly proud, like I said, to bring the legacy of Edelrid and Tree Stuff full circle with this journey, and to have you share all this with us.
Thanks
Thank
very
you.
much. Great having you here.
Yeah, really, really great.